Today, in our mathematics class, we are going to review what we did last time on adjacent angles and vertically opposite angles. We notice that in most cases, it is not always a must that we measure angles using a protractor, because there is a time when we have a pair of angles which forms special angles that we can easily calculate without any problem. So some special angles that we have are as follows. So we are going to look at pairs of adjacent angles which are special angles. Examples are the angle we are looking at here. We have the angle A or B as 90 degrees, and then angle A or C and angle C or B are adjacent angles. So these two angles, we find that A plus B should give us 90 degrees. The adjacent angles A and B gives us 90 degrees. If this is the case, then we find that the two pair of angles, that is A and B, form adjacent angles that are called complementary. So A and B are pair of angles that form complementary adjacent angles, which simply means that A plus B gives us 90 degrees. Another pair A and B in this particular case are again adjacent angles, but this time now they form two angles that lie on a same straight line. You realize that A plus B gives us 180 degrees. So if we have A and B giving us 180 degrees, we call it supplementary adjacent angles. So A and B form a pair of adjacent angles that are supplementary. Therefore, A plus B gives us 180 degrees. The next pair of adjacent angles is what forms a revolution. And when we say angles form a revolution, it means that A plus B is 360. So A and B will form one complete rotation, which we call a revolution. A revolution. So angles in a revolution form 360 degrees. So what we have here, these are two angles that are in a revolution, which implies that A and B must give us 360 degrees. So looking at problem solving, let us look at a question. So without using a protractor, find the size of the angle marked with a letter A. Marked with a letter A. This is the angle we are looking for, given that this is the diagram. So without using a protractor, find the size of the angle marked with a letter A. The diagram we have 35 degrees and we have A. You'll notice that on this diagram we have a sign of a right-angled angle, which implies that this is the two angles forms 90 degrees. So A and 35 degrees form adjacent angles. So looking at the solution, here, you'll notice that we have two angles that are adjacent, which implies that A plus B should give us 90 degrees. In this case, we have A as a known, and B is 35 degrees. So A plus 35 degrees should give us 90 degrees, which implies that A is equals to 90 degrees minus 35 degrees. 90 minus 35 degrees. You'll find that A is 55 degrees. So we have used the knowledge of adjacent angles that are complementary to calculate the size of the angle A. That is why we are able to find that A is 55 degrees, given that the two angles adds up to 90 degrees. Okay, in this question, we are supposed to find the size of the angle marked with the letter A, which is here. We have two angles. One angle is 55 degrees, another angle is A. For our solution, first we need to find the relationship between the two angles. They are adjacent, and what type of adjacent angles are these angles. You'll notice that the two angles here form what we call a supplementary pair of angles. The two angles form supplementary pair of adjacent angles. Therefore, to solve this, we find that in supplementary angles, A plus B must give us 180 degrees. A plus B is 180 degrees. For this particular case, we have A plus 55 degrees must give us 180 degrees. So our A is 180 minus 55 degrees, which will give us A as 125 degrees. So we have been able to calculate the size of this angle using the relationship of the two adjacent angles, which we said they are supplementary angles. So we are to find the size of the angle marked A given this diagram here. First, we look at the diagram and identify the relationship between these angles. You'll find that the three angles will form a revolution. And we said earlier on that a revolution means that the sum of the angles is 360. degrees. Also, we should be able to identify this sign here. What does it imply? When we have a sign like this, it simply means that this is equivalent to 90 degrees. Therefore, the size of this angle here is 90 degrees. For a revolution, we shall say that A plus 90 plus 120 is equals to 360. A plus 90 degrees plus 120 degrees is equals to 360 degrees. So we need to find the size of A, and you'll notice that A plus, when you combine these two, we shall have 210 degrees, should give us 360. So A plus 210 degrees is 360, which implies that A is 360 degrees minus 210. A is 360 degrees minus 210 degrees. Therefore, A is 150 degrees. So we have been able to calculate the size of the angle A, given that the three angles form a revolution which sums up to 360 degrees. Therefore, using the relationship of revolution angles, we are able to find the unknown angle as 150. Now, looking at application questions which relates to the problems we've covered, we want to look at the following exercise. Find the value of the angle marked with the letter A. And here, so this question, we have the angle A minus 60 degrees, and this side we have A plus 60 degrees. So the two angles are forming a revolution. They form a revolution. So the question is, find the value of A. That is what we are supposed to calculate and find. So given that this is a revolution, looking at our solution, this is a revolution, which implies that the sum of all these angles are supposed to give us a total of 360 degrees. Therefore, we shall say that A minus 60 plus A plus 60 is equals to 360 degrees. A plus 60 degrees plus A plus 60 degrees is 360 degrees. Opening up the brackets, we shall have A minus 60 plus A plus 60, which forms 360. So, collecting like terms, we shall have A plus A, which is 2A, minus 60 plus 60 simply gives us as 0, because this is minus 60 plus 60 is the same as 60 minus 60, which is a 0. So 2a is equivalent to 360 degrees. Simplifying by dividing both sides by 2, you'll find that a is equal to 180 degrees. Now, if a is 180 degrees, the size of this angle, this other side, was given as a minus 60. So for us to know the size of this side, we shall say a minus 60 degrees, and a is 180. Therefore, 180 minus 60 degrees will give us 120 degrees. So the size of this angle here is 120 degrees. Now, for the other side here, where we have a plus 60, and substituting 180 degrees with a, we shall find that a plus 60, where a is 180, it will be 180 degrees plus 60 degrees, which gives us 240 degrees. So this one forms a total angle of 240 degrees. So we have been able to calculate the value of a, and as well as the value of the angles as given in the diagram. Another last problem, again on the same problem solving. We shall look at the question . Now, these are two adjacent angles. The question says find value of A. We have two adjacent angles, both of them reading 2A and 2A. So we need to find the value of A. In our solution, first of all, we identify the two pairs as what type of pair of angles. You'll notice that the two pair of angles form what we call a supplementary pair of angles. Supplementary angles means that A plus B should give us a total of 180 degrees. For this particular case, what we have is 2A plus 2A should give us 180 degrees. Given that A and A are like terms, we can combine this so that we can have a total of 4A giving us 180 degrees. But our interest is to find the size of A, which implies we shall simplify by dividing by 4, and we remain with A is equals to 45 degrees. A is 45 degrees. Therefore, this one side where we have 2A, we can now simply agree that if A is 45 degrees, then 2A will mean it is 2 times 45, which is 90 degrees. And we have 2A here, we have 2A in this other side, which implies both sides have 90 degrees, when given that A is equivalent to 45 degrees. Lastly, on the similar problem again, now this one is a little bit involving, but we are still going to find the value of A. In this case, we have one of the angles with the sine of a right angled angle, which means it is 90 degrees. This one is 100 degrees. This is 110 degrees. And this one is A. So in our solution, we need to find and identify the relationship of all these four angles. And you'll notice that the four angles forms a revolution. Then the question comes, what is the relationship about revolution angles? You'll notice that all revolution angles, the sum should give us 360 degrees. Therefore, all the angles that we have here are supposed to add up to 360 degrees. So adding them together, we shall have A, which is here, plus 110, plus 100. This side stands for 90 degrees, so plus 90 degrees should give us 360 degrees. Summing everything up, this is 110 plus 100, that is 210, plus 90, that is 300. So A degrees plus 300 degrees should give us 360, which implies that A is equals to 360 minus 300, which is 60 degrees. So you have been able to find the value of A as 60 degrees. That is it, how we handle problems about adjacent angles, angles that are having a special relationship, where we say this special relationship falls under the category of complementary, supplementary, and revolution. So the adjacent angles that forms these can be solved in the manner that we have been able to handle. Let us look at transversal lines and parallel lines. Transversal lines and parallel lines. Now, a line is simply called a transversal when it cuts across other two lines. It can be two or more lines, but mostly when a line cuts across two lines, we call it a transversal line. A good example of transversal line, we look at the roads. We can have a road maybe moving in that direction, and then another road cuts across. You see, this road here is simply like a line, which we have two pairs, and then this other road that cuts across is a transversal. And in most cases, you'll find that any transversal line forms so many angles, and those are the angles that we are going to look at. Okay, we have a pair of lines. We have two lines here and a transversal. We have another pair of lines here and a transversal. I want to say this, that a transversal line is a line that cuts across two lines. It's not a must that the two lines must be parallel. No. They can be not parallel, like the situation, the first situation here, or they can be parallel, like the second situation here. Therefore, any line cutting across two lines forms a transversal line. We shall find that if a transversal line cuts across two parallel lines, then it gives us some relationship or angles. It creates angles that form a certain relationship, which we are going to look at in this particular case. All in all, we want to say that any line that cuts across any two lines is a transversal line. Now we want to look at what relationship does a transversal line form when it cuts across the parallel line. That is the situation number 2. So we have transversal line crossing across the two, and I want us to concentrate on the following. We have an angle formed here, and another one is formed here. I'll put an X. There is another angle formed here. And here. Now, this is a dot and an X. It simply means these two angles, the two angles that we have, corresponds, but they are not equal. For this particular case here, two angles here corresponds and are equal. What are we trying to say here? We are trying to say this, that transversal line cutting across now, we are saying transversal line cutting across two lines will form pairs of angles. The first pair of angles is what I'm going to call corresponding angles. And I've shown with a red marker that this angle corresponds with this one corresponds with this. Because these two lines here are not parallel, then the two angles that corresponds are not equal. That's why we have a dot and an X. For this one, the two lines are parallel and the two angles are corresponding. We have a dot and a dot, which simply means if the lines are parallel, then a transversal line forms two equal corresponding lines. This angle corresponds to this. This is simply to show the position of those angles which corresponds. Now, the next pair of angles formed by a transversal line which crosses two lines is what we call alternate angles. And alternate angles, they are angles on the opposite sides of a transversal line, like we have it here, opposite sides of a transversal line, and inside the lines. It's inside the two lines. So these two angles are alternate angles, as well as this. Now, for this case, these two lines are not parallel. We have a dot and an X, means that the two angles the two angles are alternate. However, they are not equal because they are not parallel. So this angle and this one are alternate but not equal. But for this particular case here, the two lines are parallel. These two angles are alternate and they are also equal. So when a transversal line crosses two parallel lines, it forms alternate angles that are equal. That is the second pair of angles formed by a transversal line. The last pair of angles formed by a transversal line when it cuts across two lines is a pair that we call co-interior angles. Co-interior angles are those angles which are on the same side of a transversal line but inside the angles. As shown on the diagram here, these two angles are co-interior as well as the two in this particular case. Now, what is the relationship? Already we find that this one shows us that the two angles are not equal. Same applies to this, that the two angles here are also not equal. However, we can identify the relationship of cointerior angles on parallel lines as follows. So we say that cointerior angles in this particular case here, they are supplementary. Cointerior angles of parallel line, not unlike parallel ones, of parallel lines are supplementary. Taking you back to what supplementary means, it simply means that the sum of any two angles that are supplementary should give us a total of 180 degrees, which implies that the angle here at the point marked X and the angle at the point marked with a dot should give us 180 degrees. So we can use the relationship of cointerior angles to calculate unknown angles given that the two angles are cointerior and the transversal line is on a parallel, a pair of parallel lines. So this is cointerior angles. That is the third relationship of pair of angles which share a transversal. So in general, we can simply conclude and say the following. So we want to say that, in general, if a transversal line crosses two parallel lines, then corresponding angles formed are equal. Corresponding angles for this particular case here, I'll use green to mark, is like this, A and B. These two angles are corresponding and are equal. 2, if the transversal line crosses two parallel lines, then alternate angles are equal. To find alternate angles in this particular case, we shall notice that the alternate angles, the one I've used the dot to mark, these two angles, this one and this, are alternate and therefore they are equal. And conclusion number 3 is that if the transversal line crosses two parallel lines, then cointerior angles are supplementary. When we say cointerior angles are supplementary, we simply mean that A plus B should give us 180 degrees. How do we identify cointerior angles? We have an angle here and we have another angle here. These are cointerior angles, and we are saying the relationship between the two is that they form a supplementary pair of angles. That is the general conclusion about a transversal line crossing two parallel lines. Now, we are going to look at problem solving given that we have a transversal line and parallel lines. How do we tackle problems related to this? Now, in our question and the diagram that we have, the question is asking us to name the angles, the angle that is 1 corresponding to angle ABF. Angle ABF. ABF. This is the angle. We are supposed to find out what angle corresponds to ABF, what angle is alternate to ABF, and what angle is cointerior to ABF, and finally vertically opposite to ABF. I'll use another different pen to show the illustration or the solution so that we don't repeat the drawing, the diagram. Now, the first is telling us to find the angle that corresponds to ABF. The angle corresponding to this. You'll find that this is the angle we are looking for. The other angle that corresponds to this in this particular diagram, it means that we should have a transversal line and the two angles should be on the same side. So you'll notice that the angle that we have, HFG, angle HFG corresponds to angle ABF. So this is the angle that we are looking for. So we indicate that with a red mark that this angle HFG corresponds to ABF. So for the first part, we shall say the angle that we require here is the angle HFG. Second part, alternate to angle ABF. ABF. When they say angles are alternating, these two angles should be inside the transversal line and on the opposite sides. If this is the angle we have, the angle that we have is ABF. To find the alternate angle should be inside the two lines, but on the opposite side of the transversal line. You'll find that that angle is this one here. That's the angle BFE. Angle BFE is alternate to ABF and they are equal. So we shall say that the angle that is alternate to ABF is angle BFE. That is this angle here. C is asking for a pair of cointerior angle. Which angle is cointerior to ABF? Cointerior angles are angles on the same side of the transversal line and inside the parallel lines. You'll notice that when you talk of cointerior angles, it is the line, the angle marked with an X, which is both inside the parallel lines and on the same side of the transversal line CG. So you'll find that the angle we are looking for here is the angle BFH. So the angle that is cointerior to ABF is angle BFH. BFH. This is the angle. So the two angles are cointerior. And lastly, the angle that is vertically opposite angle ABF. Angle ABF. This is ABF. Vertically opposite is just directly on the opposite side. You'll find that this is the angle we are looking for, and this angle is CBD. So the angle here is angle CBD. This angle CBD is vertically opposite angle ABF. That is what they are asking us to find in this particular case. Now, this question is asking us to find the value of A in the diagram and give reason for your answer. Find the value of A in the diagram and give reason for your answer. Here, this is the diagram that we have. This diagram has two parallel lines. It has a transverse. One of the angles here is 115 degrees. Another angle here is A. We are supposed to find A. In our solution, in this particular case, we need to identify what is the relationship between these two angles, that is the 115 degrees and A. You'll notice that the two angles are alternate angles. They are alternate angles. If that is true, then we find that A is equal to 115 degrees. And why we say this is that alternate angles, the two angles, we've said they are alternate angles, and the reason why they are alternate, we said they are falling on the opposite side of the transversal line inside the two parallel lines. And we say that if the angles are alternate, then they are equal given that the two lines are parallel. But note that we have been asked to state the reason or to show the reason for our answer. The reason here is that alternate angles in parallel lines are equal. That's what it is. We have identified they are alternate, and we have said it is 115. Why? The reason being that alternate angles are always equal given that the two lines are parallel. So alternate angles in parallel lines are always equal. That is the reason we give for this particular case. So this one is the reason to explain why A is equals to 115. In this diagram, the question remains the same. Find the value of A. Find the value of A and give reason for your answer. So first, we need to look at the relationship that exists between these two angles. You'll find that the angle that we have here is 55, and for our solution, A is not anywhere closer or inside the two parallel lines, but it is outside. So we need to look at it from a wider perspective. So we shall find the other angles that we are able to get. For example, this angle here is alternate to 55, which implies that this angle is 55 degrees. Then you'll notice that the relationship between A and 55, the two angles are on the same straight line, and they form supplementary pair of angles, which implies that A plus 55 is equals to 180 degrees. So A plus 55 is equals to 180 degrees. Therefore, A is 180 minus 55 degrees. A will give us 180 minus 55 degrees. So you'll notice that when you subtract that, you'll notice that the A is 125 degrees. It is simply on the same straight line and it forms supplementary. However, the knowledge to get this 55 was because they are alternate angles. So the angles here again, we have to find A in this diagram giving reason. Our solution, we shall be required to find the relationship between the two angles here. And the two angles here, their relationship is that the two angles are co-interior. They are co-interior angles. And we say that when two angles are co-interior, then it implies that the sum of the two angles, that is A plus 110 degrees, should give us 180 degrees, which implies that A is 70 degrees. A is 70 degrees. The reason why we are saying that it is 70 degrees, we say that co-interior angles in two parallel lines form a supplementary, which implies that A plus 110 is 180. So we've been able to get A because they are co-interior and they form supplementary angles. So this is how we can solve questions related to co-interior angles, alternate angles, and corresponding angles. Next, I want us to look at proving that two lines are parallel. How are we able to prove that two lines are parallel? Proving lines are parallel. I'll use freehand in drawing this and illustrating. So we have the angle here is 75 degrees and 78 degrees. Question: prove if the two lines here are parallel. So our solution, we shall say that these two lines are not parallel. They are not parallel. Then the question comes, why? We must explain the reason for our answer. Why? Reason being that the two angles are alternate, but they are not equal. If alternate angles are not equal, then it implies that the lines are not parallel. Because parallel lines, alternate angles must always be equal. So for this particular case, we are saying they are not equal because 75 degrees and 78 degrees forms alternate angles, but they are not equal. Therefore, the two lines are not parallel. Second question. We have two parallel lines with a transversal line, but forming 122 degrees and 58 degrees. Our solution, we first identify that the two angles are co-interior. Then the second one, we prove what is the relationship between these two angles. The relationship, if the two lines are parallel, then it means that they should form supplementary. which implies that A plus B is 180. Let us see. 122 degrees plus 58 degrees. Does it give us 180 degrees? You'll find that it is 180 degrees. And if that is true, then the two angles are cointerior. The two angles form a supplementary. That is, they add up to 180 degrees. Therefore, the two lines are parallel. So we have been able to identify that these two lines are parallel and these two lines are not parallel. So in general, we find that it is very easy for us to use a transversal line given parallel lines to solve so many angle-related problems. And it's always good to know the relationship that connects the angles of transversal line on a parallel pair of lines. So this is our question. Name the angles. So remember the angle that is corresponding to angle EBH. Angle EBH. EBH. We are looking at this angle here. B alternate to EBH, cointerior to EBH, and vertically opposite to EBH. We are to find the angles that are corresponding to EBH. Let us start with the first part, corresponding to EBH. I'll use a different pen to illustrate that. Now, EBH is here. This is EBH. We are looking at this angle. The angle that corresponds to EBH, it means that this angle should be on the same side of the parallel lines and on the same side of the transversal line. So you'll find that this angle here, I'll put an X, and this angle here simply corresponds. So the answer for this is FEG. Angle FEG. So FEG corresponds to EBH. Alternate to EBH. Alternate to EBH. It is supposed to be inside the parallel lines on the opposite side of the transversal, which implies that it will be this one here. So this angle is alternate to this. What angle is this? This angle is angle DEB. DEB. So we shall say that angle DEB is alternate to this. So the answer here is angle DEB. Cointerior to EBH. Cointerior are the angles which are inside the two parallel lines but on the same side of the transversal. So if we have EBH as this, then the cointerior should be this one here. I've used a dot because the two angles are not equal. So what angle is this? This angle is BEG. Angle BEG is cointerior to EBH. So the answer here is BEG, angle BEG. And finally, vertically opposite to EBH. If this is EBH, vertically opposite is directly on the opposite side. You'll find that the point here, which is CBA or ABC, forms a vertically opposite angle to EBH. So the answer for this is angle ABC. It's supposed to be vertically opposite and is always equal. So that is it for today about transversal lines and parallel lines. Thank you.